Welcome to video lesson 9.5. This is where we're going to look at perfect square trinomials. Go ahead and put today's date in the top right hand corner. And our target for today is that I can simplify my answer for perfect square trinomials. So as far as factoring, we factor perfect square trinomials just like we factor the regular trinomials. The only exception is that we have to first check, make sure our first coefficient A and our last constant C are perfect squares. So if they're perfect squares, I can save myself a little bit of work. Alright, for finding the factors of A and the last number, our C, use their perfect squares and add the middle, B, as normal. So that part doesn't change very much. So for finding the factors of A first, like how we deal with our 9-4 notes, we find our factors of C like we usually do, two numbers that multiply to the last, and add to the middle. Okay. If it is a perfect square, the two parentheses will be the same. So if you think about two parentheses being the same, that means I have two of the identical parentheses, so I can raise it to the second power. So let's factor some trinomials using what we learned today. We got to check, make sure they're both perfect squares, and then we factor like normal. Okay, so let's see. Our first example has 4x squared plus 12x plus 9. So we look and we check our A, so our coefficient in front, our leading coefficient, and it's a 4. 4 is a perfect square. If you remember from our perfect square list we made in our DOS notes. So 4 is a perfect square. Then we check our last number, which is our constant, 9. 9 is also a perfect square. So what that means is whenever I go to factor this trinomial, I always check for GCF first, so 4 can't go into 9 evenly, so 4 is a perfect square. So I need to use the numbers that make 4 a perfect square, and 4 is made by 2 and 2. Same way when I find two numbers that multiply to our last, 9, I need to use his perfect squares. So I need to make the numbers that make him a perfect square, which is 3 times 3. Now the addition step is the only one now I have to check and make sure it works. So if you remember from the addition step of normal trinomials, we come over here, we take our factors of our leading coefficient, 2 and 2. We put 2 times, 2 times. Then we put the numbers we found here on our multiplication, so 3 times 3. And we say 2 times 3 and 2 times 3. So 2 times 3 is 6, plus 2 times 3 is 6, and 6 plus 6 is 12. So we check. So our leading coefficient was 4, and he was a perfect square. Our last constant was 9, and he was a perfect square. So I just used their numbers. So now we write out our answer. We got our two parentheses. I have to use the numbers I used for 4, and we used 2 and 2. So 4x squared is going to be a 2x and a 2x. Now, over here, our addition step, we look, we say 2 and 3 have to be on our outside. So 2's on the outside, so we have to put our plus 3 over here in our second one to be the outside. And 2 and 3 have to also be our inside. So our plus 3 goes into our first one. There we go. And before I go any farther, let me make sure this checks. So we do 2x times 3 is 6x. 3 times 2x is 6x, and 6x plus 6x is 12x. That means we check. So right here where we have the same parenthesis, 2x plus 3 and 2x plus 3, that means I can write it once, 2x plus 3, and put it to the second power to show I have two of them. And that's a perfect square trinomial. So let's see our second example. We have to first make sure it's a trinomial. It is. If you check it, our leading coefficient is 4, and we just said from our last example he's a perfect square. Our last constant is 16, and he's a perfect square. But if you remember, our very first step for all of our different types of factoring, no matter what it is, even if it is for trinomials, we always check for GCF first. So if you look, I have a 4, which 4 can go into 18 evenly. And then 4 can also go into 16 evenly. So this one has a GCF of 4, and they don't have any A's in common. So now I have to take out my GCF first before I can do anything else. And 4 drops on the outside, and now we divide. 4 divided by 4 is 1, so our A squared drops. Negative 8 divided by 4 is negative 2A. And then plus 16 divided by 4 is 4. So after I take out my GCF, if you look inside here, we can check it. So technically our coefficient here in front of our A squared is a 1, and 1's a perfect square, and 4 is a perfect square. Now, because our leading coefficient's 1, we don't have to show it. So this is one of those, I can just go back and try the basics. So 2 numbers that multiply to the last, and 2 numbers that add to the middle, which is a negative 2. And because 4 is a perfect square, I need to try his perfect square. So 2 times 2 is 4, but 2 plus 2 is positive 4, not negative 2, so that's not going to work. So where this is multiplying to a positive, maybe if I try 2 negatives, negative 2 times negative 2 gives us positive 4, but negative 2 plus negative 2 gives us negative 4, so that doesn't work either. So what that means is not only can I not factor this middle part, but the middle of our parentheses is not a perfect square trinomial. So after we take out the GCF, that's as far as we can go. So this is our answer. All I could do for this one was just take out the GCF. And our last example has 3x squared. So we have 3x squared minus 12x plus 12. If you all remember from our last example we did, the very first thing we got to check for is our GCF. So we check 3. Can 3 go into 12 evenly? Yes, it can. And then we try 3. Can it go into 12 evenly? Yes, it can. So I have a GCF of 3. They don't have any variables in common, so I just take out my GCF of 3. So 3 divided by 3 is 1. I don't have to show it. Make square drops. Negative 12 divided by 3 is negative 4. Our x drops, and 12 divided by 3 is 4. Okay, so now we look into our parenthesis. He's a trinomial. So we got to check him to see if he's a perfect square trinomial. So leading coefficient here is technically 1. So 1's a perfect square. Our last constant is a 4, and he's a perfect square. And because our leading coefficient's 1, we just have to set up for our basic trinomial where we find 2 numbers that multiply to our last of 4, that add to our middle, which is negative 4. And because 4 is a perfect square, I need to try perfect squares first. So 2 times 2 is 4, and then 2 plus 2 is positive 4. So I need to go back to my multiplication step and say I need to make both my 2's negative. So negative 2 times negative 2 gives us positive 4, and negative 2 plus negative 2 gives us negative 4. So I found my numbers that work. Now remember, because I did have a GCF, I can't forget about him. He has to drop down 3. Then trinomial breaks apart into 2 parentheses. And I start out with a 1x squared, so that means I put a 1x and a 1x first in both parentheses. And my numbers are the same. I have a negative 2 and a negative 2, so x minus 2 and x minus 2. Now, we look right here at this step, and I have two of the same parentheses. I have x minus 2 and x minus 2. So, still dropping down my GCF of 3, I can just write x minus 2 once and square the parenthesis to show I have two of them. And that's our final answer. And that finishes up for perfect square trinomials.